All right, in this lesson, we're going to talk about the factor theorem and the remainder theorem. And so I'm just going to start with an example, and then we will go back to formalize what these theorems are. And so starting with example 1, it says use synthetic division to determine if x minus 4 is a factor. And so if x minus 4 is a factor, we would get a remainder of 0. And so, for example, if 5 is a factor of 20 because 5 times 4 is 20. And so if I divide 20 by 5, I'm going to get 4 with a remainder of 0. And so we are looking for a remainder of 0 when we do this synthetic division. And so to set up your synthetic division, you need the coefficients of the dividend, which in this case is 1, 1, negative 13, negative 25, and negative 12. Not missing any of our terms, so we don't need any placeholders. And then the root of this divisor would be 4. And so first step, bring down the 1, multiply. 1 times 4 is 4. Add these two numbers and you get 5. Multiply 5 times 4 and you get 20. Add these two numbers and you get 7. 7 times the 4 is 28. Add these two numbers and you get 3. 3 times 4 is 12. Add these two numbers and you get 0. This last number is always your remainder. And so here we're looking for a remainder of 0 and we got it. And so yes, x minus 4 is a factor of this polynomial. And the polynomial's name is f of x. Okay, and so what the factor theorem says is that in general, if something is a factor of a polynomial, for example, if x minus a is a factor of f of x, that means a is a root, okay? A is a root. So when we are dealing with quadratics, if I had factors x minus 5, x plus 2, the roots would be x equals 5 and x equals negative 2. And so for this specific example, x minus 4 is a factor of the polynomial. So that means x equals 4 is a root. And so this synthetic division is really helpful because if we can find a factor, we can find a root. And so the remainder theorem says that if you divide any polynomial by a linear factor, whatever the remainder is, whether it's 0 or not, that's going to be the result of plugging that root into the function. So, for example, on example 1, the remainder was 0 when we divided by x minus 4. And so if I were to plug in 4 to the polynomial, I'm going to get 0 as an answer. And so we can also use synthetic division to solve for what f of 4 is by just using synthetic division. Okay, and so it's going to be the remainder when we divide by x minus 4. Okay, and so we want to put the 4 here. We don't want to change the sign. We're going to put this exact number on the outside for our synthetic division. And then just like the last example, we still need the coefficient. So we need the 1, the negative 6, the 8, the 5, and the 13. We bring down the 1. 1 times 4 is 4. Add these two numbers and you get negative 2. Negative 2 times 4 is negative 8. Add these two numbers, you get 0. 0 times 4 is 0. Add these two numbers, you get 5. 5 times 4 is 20. Add these two numbers, and you get 33. And that is your remainder. And so this 33 is actually going to be the result of f of 4. You can type that into your calculator, but synthetic division is way easier than substituting 4 for all of these x's and then trying to number crunch all of that. Okay, so on example 3, we're back to determining whether or not x plus 2 is a factor. And so we're looking for remainder 0. And so to set this up, the root would be x equals -2. And then the coefficients are 3. We're missing the x4 term. And then -5. We're missing the x squared term. We're missing the x term. And then we have the constant term. So lots of placeholders here. Bring down the 3. 3 times -2 is -6. Add these two numbers and you get -6. -6 times -2 is 12. Add these two numbers, you get 7. 7 times -2 is -14. Add these two numbers, you get -14. -14 times -2 is 28. Add these two numbers, you get 28. 28 times -2 is -56. Add these two numbers, and you get 1. And so 1 is our remainder. Because that's not 0, we don't even really care what that number is for this problem. It's not 0. And so because that's not 0, we know x plus 2 is not a factor. For example number 4 and example 5, divide using synthetic division and then determine, is the following binomial a factor of the polynomial? Okay, and so here we're gonna use our synthetic division. X minus 4 has a root of x equals 4. And so collecting our coefficients, we're gonna need lots of placeholders. 1x cubed, 0x squared, 0x, and -64 for the constant. Bring down the 1. 1 times 4 is 4. Add, you get 4. 4 times 4 is 16. Add, you get 16. 16 times 4 is 64. Add, you get 0. And so the result of this division, you always drop your original degree by 1. So this would be our x squared term, followed by the x, followed by the constant. And because we have a remainder 0, we do not write that in our answer. And so the result of the division, or the quotient, is x squared plus 4x plus 16. So if the problem wants you to find the quotient, you're done. That's the answer to A. The answer to B is yes. X minus 4 is a factor. Because the remainder is 0. We got a remainder 0, and so that's how we can determine, yes, it is a factor. Example 5, starting with part A, we're just going to do the division. And so the root of the divisor is 2. And then the coefficients are 1, -1, missing the x squared term, and then our x term, and then our constant. Bring down the 1. 1 times 2 is 2. Add, you get 1. 1 times 2 is 2. Add, you get 2. 2 times 2 is 4. Add, you get 6. 6 times 2 is 12. Add, you get 10. And so the result of our division for part A, we need to drop this degree by 1. So this is our x cubed term. So we have x cubed plus x squared plus 2x plus 6. And then that 10 is our remainder. So 10 over the divisor, which is x minus 2. And so this is the answer to part A. And the answer to part B is no. X minus 2 is not a factor. The remainder was not 0. It was 10. Example 6, show that x minus 2 is a factor of this degree 3 polynomial, then find the remaining factors. So this is where we really want to apply our synthetic division, is to find other factors. And so starting with x minus 2, they're telling us it's a factor, so we should get a remainder of 0. So the root of x minus 2 is x equals 2. That's why I wrote the 2 down. And then our coefficients are 1, 7, 2, and negative 40. We're not missing any terms. So we bring down the 1. 1 times 2 is 2. Add, you get 9. 9 times 2 is 18. Add, you get 20. 20 times 2 is 40. And we get that remainder of 0. Okay, and so x minus 2 is a factor, so therefore, this symbol means therefore, x minus 2 is a factor. And so what we're left with is our original quadratic was degree 3, and so this is going to be degree 2. And so our result is x squared plus 9x plus 20. And we can actually factor that. That's a quadratic. We know how to factor. We need two numbers that multiply to 20, but add to 9. Those numbers are 5 and 4. And so this quadratic factors to x plus 5 and x plus 4. So this degree 3 polynomial in his factored form would be x plus 5, x plus 4, and the x minus 2 that they already gave us. And so if you have one factor, you can divide it out using synthetic division. And once you have that remainder of 0, it usually leaves you with something you can factor easily. And so this is helpful for this particular problem because this degree 3 polynomial isn't factorable by grouping. If you tried to group the terms, you would factor out an x squared and be left with an x plus 7. And then out of the second term, you would factor out a 2 and then be left with an x minus 20. These don't match. And it's not because you did anything wrong. It's just not factorable by grouping. And then when you have a degree 3 4-term polynomial that you can't factor by grouping, it doesn't mean it's prime. It's just you need another method. And the method is to find a factor, here they gave it to us, and then divide it out. And once you divide it out, you'll be left with something you can factor. To use synthetic division, the divisor must be of form x minus a. The coefficient of x in a divisor is not 1. You can rewrite the division expression so that you can use synthetic division. Okay, so here's an example of synthetic division where our coefficient isn't 1. We haven't done one of these yet. And so if your coefficient isn't 1, you just have an added step. And so you still set it up the same way. And so here our coefficients are 2, 17, 23, and negative 42. And then the root of our divisor is actually going to be a fraction this time. And so if you set 2x plus 7 equal to 0, you would subtract 7 and then divide by 2. And so the root of our divisor is negative 7/2. And so even though it's a fraction, we're still going to be able to do our synthetic division the same way. There's just going to be an added step at the end. So you bring down your 2. 2 times negative 7 halves is negative 7. Add, and you get 10. 10 times negative 7 halves is negative 35. Add, and you get negative 12. Negative 12 times negative 7 halves is positive 42. Add, and you get 0. And so 2x plus 7 is a factor, and so we should have gotten 0 as a remainder. But this quotient here that we're left with, it's scaled by whatever this denominator is. So that's always going to be a GCF. The denominator will be a GCF that you can divide out. You don't care that this is negative. You ignore that part, but you do need to divide these remaining numbers by 2. So that leaves us with a 1, a 5, and a negative 6. So the quotient is actually x squared plus 5x minus 6. So you always need to divide out that GCF before you commit to your final answer. And so this quadratic is factorable. You finding two numbers that multiply to negative 6, but add to the 5. Those numbers would be positive 6 and negative 1. And so the factors are x plus 6, x minus 1. And so they told us 2x plus 7 was a factor. And this too is not a GCF of the polynomial. It was a random scaling that we ended up with as a result of our root being a fraction. So you're not going to want to put that 2 in your final answer. So the 2x plus 7 gets to be in the final answer, as well as the x plus 6 and x minus 1. So the factored form of this degree 3 polynomial is 2x plus 7, x plus 6, x minus 1. And then if you were to multiply all of this out, you would get a 2x cubed and all of these other terms. So it's always good to check your work. 2x times x would give you a 2x to the third as your leading term. And then I always like to multiply the constant. 7 times 6 is 42, times negative 1 is negative 42. And so our constant is correct too. So that's just a quick way to spot check your work to make sure you have all the factors correct.